MuleSoft provides multiple deployment models to cater an organization's security or application infrastructure requirement. Depending upon the use case, one can choose between CloudHub, Hybrid, Private Cloud Edition, Pivotal Cloud Foundry, and Runtime Fabric deployment models. In this video, we will have an overview of the different deployment models provided by MuleSoft. As usual, I have placed the video timestamp in the description below so that you can easily navigate across the subtopics of this video. Let's get started. I'll first try to create a base by explaining the Anypoint platform components, as all the deployment models hover around the different combination of these components. The first component is the Anypoint Design Center that helps you design API, that is, create a RAML or OS spec using the API designer. Flow Designer is a web-based UI that helps us in creating Mule flows at the convenience of the web browser. However, the MuleSoft Anypoint Studio is a full-fledged Eclipse-based IDE that allows you to create, build, and deploy applications to CloudHub. Mule SDK helps in creating custom connectors, which again can be created using any Eclipse-based IDE or even Anypoint Studio for that matter. Next up, we have the Anypoint Management Center. Now that we have created the APIs using the API designer, we need to manage them by applying different policies. And the API manager helps us to do the exact same thing. API implementations are Mule applications deployed to a Mule runtime. So to deploy the applications to a runtime or get workers assigned and create a runtime in the workers and then deploy it to the worker, we need runtime manager. The runtime manager also helps us in scaling the application horizontally or vertically by increasing the vCore size. Analytics related to the API usage, like the number of requests in a time frame or the HTTP status codes or any violations, are also provided by the Anypoint Management Center. Access management, as the name suggests, helps in providing roles and permissions to the user. Now there is a third component that acts as a link between the Anypoint Design Center and the Anypoint Management Center, and it is the Anypoint Exchange. Any asset like the API connector templates that we create has to be published to the API to the Anypoint Exchange, and it acts as a source control management. And then suppose if we want to apply policies to the API, we import that policies from the Anypoint Exchange into the API manager and apply the policies. Or else if you want to import a custom connector that has been published to Exchange, all we have to do is add the Anypoint Exchange dependency of that connector in the pom.xml. Next up is the Mule runtime engine that provides an environment for the Mule applications to run, and it is supported by the multiple MuleSoft runtime services like the Anypoint messaging queue, the Object Store v2, the persistent queue, which are backed by Amazon SQS, the enterprise security, and Fabric. Now remember, this services like the Anypoint MQ, Object Store, and persistent queues. Persistent queues are available on-prem, but Object Store v2 and Anypoint messaging queues are available only on CloudHub, and the Amazon-backed persistent queue using SQS are also available on CloudHub. Now, if I divide this diagram symmetrically across the x-axis, I realize that there are two planes. One is the control plane and the other is the runtime plane. Now the reason it is called as the control plane, because all the components over here are in short doing the task of controlling, and that's the reason we call it as a control plane. Whereas in the lower region, they all provide an environment for the applications to run. So that is why it's called as the runtime plane. Now, depending upon the location of the control plane and the runtime plane, we have the multiple deployment models. So let's now see each of the deployment model in the next slides. So now the first deployment model that we are looking at is the CloudHub model. So in this particular model, the control plane and the runtime plane are both on MuleSoft's CloudHub, and this CloudHub is backed by Amazon's AWS. Okay, and now if there are some on-prem system, which obviously are in case at your data centers, and we want to communicate from our CloudHub applications, because all of them are hosted on CloudHub, so we would need a VPN connectivity from CloudHub to the data center. Now the catch over here is, if you want to have a VPN connectivity, you need to have a virtual private cloud subscription. So we have to get a virtual private cloud subscription. And what are the benefit of having VPC? That you can establish a VPN connectivity to secure the connection from CloudHub to the data center. Apart from that, you have the ability to configure a dedicated load balancer. So the dedicated load balancer allows you to host your organization's certificates and also apply vanity domain names, for example www.vishwas.com and then /API and all those sorts of things. So that can be done using DLB. But if you do not configure DLB, it's still fine. Even in VPC, it can still use the CloudHub shared load balancer, but the only thing is that you will get a .cloudhub.io domain name, and whatever certificates you configure, those will be overridden by the MuleSoft SLB's certificates. So that is a catch over here. So now as we discussed, it is a MuleSoft managed cloud which is backed by AWS. And when should we go with the CloudHub model? When the organization wants to get rid of all the infrastructure management. They do not want to manage any infrastructure. They just want to create the code and just deploy it right away. So in that cases, we can use this type of deployment model. Now, what are the benefits of this deployment model? First of all, it is hassle-free deployment. You just need to deploy the code to CloudHub. That's it. Or you can also automate using the Mule Maven plugin. And what does it mean by zero downtime upgrade? Suppose you have a new version of your application which you want to deploy. So if when you deploy the application, the previous version of your application continues to run unless and until the new version gets deployed completely. So any new traffic, it won't happen that while deploying the previous version would get undeployed and the new traffic has to wait, or they might get some delay of service. No, they will be continued to be served by the previous version until and unless the new version is deployed and fully up and running. That is meant by zero downtime upgrades. It provides out of the box scalability. So it provides horizontal as well as vertical scalability. So when I say horizontal scalability, you can increase the number of workers and scale your application on multiple workers. And when I say vertical scalability, you can increase the size of worker by using 1 vCore, 0.2 vCore or 0.1 vCores, right? Then you have access to object store v2, Anypoint messaging queue and persistent queues which are backed by Amazon SQS. So these services are exclusively applicable only when your runtime is present on the CloudHub. Now, what are the cons of this type of model? First of all, domain projects are not supported. Why? Because every worker has one particular Mule runtime, and that Mule runtime can host only one application. So for a domain project to work, you should have a Mule runtime that can host multiple Mule applications, whereas that is not the case over here. So if you are already using domain projects, this might require some changes to your code and you won't be able to leverage the domain projects anymore. Workers could be expensive. Yes, a 1 week core can cost you up to $19,000 per year. So of course they can be expensive. VPC and VPN charges are extra. Like I said, if you want to securely connect to your data center from the CloudHub, you need to have a VPC. And then if you want to have a dedicated load balancer, again you need a VPC and a VPN also. So those charges are extra, so you might want to consider those as well. Now, considerations for isolation from public cloud: VPC are required, that we have already discussed. VPN tunnel required for communication with on-premise system, and this would incur added latency, obviously, because if it is on cloud and this is at your data center, then there will be a communication gap, so it will incur some latency. And DLB should be configured for vanity domains. Like we discussed, if you want our custom domains, we need to have a dedicated load balancer configured. So that was about the CloudHub model. On the similar lines, we have the hybrid model, but there is a slight difference over here. As we can see from the diagram, only the control plane is present on the cloud, whereas the runtime plane is in the data center. And how is the control plane able to communicate with the runtime plane or pass all the control instruction? It's through the runtime agent. Now, in this case, even if the control plane goes down for some reason, it's not there could be some outage. In that case also, you will be able to access or hit the services which are deployed to runtime plane. So it's not that it's completely dependent on control plane. Control plane only gives you the flexibility to just deploy the application and apply policies from the convenience of a web browser. You can also deploy the application manually to this runtime plane by just placing the jar file into the Mule runtime directory. So that can be done. So even if this goes down, there's no issue, your application continues to run. It's just that it's controlling. And how is the control established? It's established using the runtime agent. So let's see the points. MuleSoft managed control plane. Yeah, we can see it's managed by MuleSoft. When you don't want to move out of premise. So when you do not want your runtime, your application data should not move out of the premise, you can go ahead with this. And if you want the metadata is going to the control plane, that's fine. In that case, you can move to the hybrid model. Or else, if you have a long-term strategy to slowly move to cloud, suppose now your organization decides that we want to move completely to cloud, but you cannot move at once, right? It takes time, it happens in stages. So in such cases, you can have a CloudHub subscription which can allow you to host your control plane on CloudHub, and you can have your data center, your runtime plane at your data center. So you can use this strategy in such cases. Now, what are the pros? We can utilize shared resources using domain projects. Since we have one runtime and that is fully under our control, we can utilize the shared resources, right? When multiple apps in a single runtime, Mule runtime. Reduced latency, obviously, since the Mule applications are hosted in our data center and other applications are also present in our data center, the latency gets reduced, obviously. Leverage existing load balancer for vanity domain. Again, in this case, vanity domains is possible as long as we have a dedicated load balancer. Every organization will obviously have a load balancer on top of their multiple applications, so we can register these applications with the load balancer and it can direct to Mule application. So we can use the vanity domains here as well. No additional effort is required as that in CloudHub, like we need to configure the DLB. Not required here if we have already configured, not much of an effort. Now, what are the cons? Upgrades and patches we have to manage on our own. If there are any new upgrades happening to the Mule runtime or any security patch that are being released, we have to do it manually because the runtime plane is managed by us in the data center. So we have to do those things manually. Scalability needs an extra effort, of course, because this cannot be dynamically scaled as we can do in CloudHub. Like we just at a click of a button, we can change the horizontal scalability across more than one worker, or also we can increase the vCore size. But here, if you want to scale this, we need to add more servers to the cluster or create server groups. So scalability does needs an extra effort. And also, if you want to push your logs onto the control plane, if you want to monitor your logs from control plane, you would again need a Titanium subscription. Otherwise, you have to go to the log folder of your runtime plane and read the logs manually, or you can use a Splunk to fetch the logs from the Mule directory, Mule's log directory. So that is another problem. If you do not have Splunk, then you can leverage control plane, but you need a Titanium subscription. Now, consideration is that the fact that if you are using OS, if you want to leverage OS v2 service, you cannot leverage. And again, persistent queues which are backed by Amazon SQS, that also cannot be leveraged. So if you are fine with your custom implementation or your default object store v2 that the on-premise systems get, then it's fine. But if you want to particularly use the object store v2 services, those cannot be availed. Now, what we observed, one of the major problem was the scalability. Scalability needs to manually add the servers to this group, to the cluster, right? So on the similar lines, we have another deployment model which is also called as the runtime fabric model. And the runtime fabric model helps us to do the exact same thing, that is improve the scalability dynamically. So the same thing, the control plane still remains on CloudHub. So control plane is untouched, it's same as the hybrid one. The only thing that changes is the deployment mechanism at the runtime plane. So let's see this. We have a data center, then the data center has a Kubernetes cluster, and Kubernetes job is to spin up Docker containers as and when required. So depending upon the replica sets you defined or the threshold of request you define, it has the inherent ability to spin up and spin down the containers. So we have Docker containers, and the Docker containers have the Mule runtime. So that's the only difference between the hybrid model and the runtime fabric model. So runtime fabric model, this thing can also be hosted on any other cloud service provider like AWS or Azure. So here you get rid of the scalability problem. Again, now in this case also you still have to do the patching process and all those stuff manually, and also load balancing by default will be provided, but if there is a load balancer at your org level, you need to configure that. But the load balancing across the Docker containers is automatically handled by Kubernetes. So the next model is the private cloud edition model. Now in this model, the control plane and the runtime plane both are at your data center. In all the previous three models, we saw that the control plane every time was on CloudHub, was managed by MuleSoft. But in this case, the control plane has finally come to the data center, which is now managed by the organization itself. Now, when do we go with such a model? It's usually done by banks who believe that their data is highly secure and they do not want to risk, they do not want to give the data to any other organization to manage, like MuleSoft. So they do not want any other person managing their data. They want to manage their data on their own. So such organizations prefer the private cloud edition model. So this is a self-managed control plane and a runtime plane, used when security restrictions do not allow flow of even metadata out of the premises. In the hybrid and the RTF, the metadata could go to the control plane and that was completely fine. But in case if you do not even want the metadata to go to CloudHub, you can use this model. So in this model, what happens is, in the control plane you have the components like design and management center. All of these components are basically deployed into Docker images, Docker containers, and those Docker containers are managed by Kubernetes, whereas a runtime plane is having the actual bare metal infrastructure, and on top of that we have VMs, and those VMs, on those VMs we put a Mule runtime and applications are deployed. So only the control plane part uses Kubernetes and Docker, whereas the runtime plane part is our normal servers, a cluster of servers or server groups. Now the benefits of this is that control planes and runtime planes are secured by the organization. The metadata does not flow outside the data center. Everything remains at your data center, and all the exchange assets are strictly, since the control plane is on premise, the Anypoint exchange comes to on premise, and everything is on premise, not accessible outside the organization. And now the con over here is that you have to manage everything, and managing the control plane does require good amount of skills and expertise, so that usually come with time, so that could be difficult at some time. So this is the only problem with the private cloud edition model. Well, there are quite good features that are available with CloudHub, but they are not available in the private cloud edition model also. We'll see that later on, but this is one of the major cons over here. Now on the similar lines, we have something called as pivotal cloud foundry model. Even this is the same as private cloud edition. The only thing is, now in this we have a pivotal cloud foundry which is hosting a control plane and runtime plane, and the pivotal cloud foundry can be hosted on your data center, it can be hosted on AWS, it can be hosted on GCP, on any popular cloud provider. So what exactly is pivotal cloud foundry? I'll give you just a brief idea, not in detail, but just a brief idea. So what happens, you have an infrastructure, okay, and on top of infrastructure, pivotal cloud foundry provides its own container engine, which is the Garden or Diego. It came long before the Docker and Kubernetes existed. So before that, the pivotal cloud foundry already has its containerization system called as Garden. And on top of this Garden, you can deploy your application, containerized application. So what usually happens is, whenever you create a code, the code has something called as build pack. So the job of build pack is to determine what kind of application it is. So MuleSoft has created its PCF build packs, and depending using those build packs, the PCF determines that those are Mule applications and they would require a Mule runtime, and accordingly it will help to deploy the application. So that is the PCF model, and the PCF model is usually the organization add a layer of PCF on to their data center, and then on the PCF they deploy their control plane and the runtime plane. So PCE and PCF are almost similar. It's just that a layer of PCF is added on your data center, and you're hosting your control plane and runtime plane on PCF. So PCE and PCF are similar, and hybrid and RTF are also similar. So with this, we have completed all the deployment models which are available with MuleSoft. Now we'll see a quick comparison of all the deployment models. So first, let's start with CloudHub. So high availability, yes, it is out of the box. You do not need to do anything. MuleSoft provides it right away. For load balancing, you have a shared load balancer and a dedicated load balancer. If you want vanity domains or want to host your own certificates, you need to use the dedicated load balancer. And again, for DLB, you need to have a VPC, and VPC by default gives you a subscription of VPN, and using that you can connect to your on-prem systems securely. Logging is provided by default. You have logging. I think the capacity is 100 MB or 30 days by default. So if your log size exceed 100 MB, those are deleted, and otherwise if 30 days, those are deleted. So whichever comes earlier, that is. And if you want to increase the logging capacity, you need to have a Titanium subscription. Monitoring, yes, it is available out of the box. Like you get if you go with the Titanium subscription, you get features like monitoring the heap space, the CPU utilization, memory utilization, meta space. You get a wide array of metrics. So yeah, that is available. Object store v2 is also available. Scheduling is when you add scheduler to your flow as a source, CloudHub provides option in Runtime Manager to override the schedule of your scheduler. You can provide your schedule time durations using the Runtime Manager. So scheduling is available in CloudHub. Security updates, yes, those are automatically applied. You do not need to take the overhead of those. Shared resources, unfortunately no. We already understood the reason why shared resources cannot be used, and it's denoted by this symbol. You can find this icon when you open the Runtime Manager, and there you have a list of application, right? Beside the name of your application, you'll be able to see this type of icon. So this suggests that the application is hosted on CloudHub. Next we have the hybrid, and hybrid is determined by this. It's half cloud and half data center, if you can observe it. So even this icon also can be seen on the Runtime Manager depending on the type of your application. Now high availability, now again it is you have to configure it. You have to take care of high availability depending on how you have how your server is, how is the cluster. Load balancing, of course all the organizations have their own load balancer, so that is not an issue. So you have an on-prem load balancer which has its own certificates and its own domain name. So that's not much of an issue as compared to CloudHub. Logging, no, you do not get logging. You cannot see the logs on Control Plane unless and until you get a Titanium subscription. Monitoring, yes, it is available. Object store, again, if you want a detailed monitoring like heap space consumption, meta space consumption, and all those detailed monitoring along with visualizers, you need to get a Titanium subscription. Object store, again, object store v2 is not available, but by default it can persist in memory in the shared memory grid or on the persistent file system. But again, if you want another implementation, you can create your own implementation and back it by some database. So you can configure it over here, but you do not get a v2 object store access. Scheduling, no. Even if you have a scheduler, you have to put the schedule frequency inside the Mule application itself. You cannot control it from the control plane, so it's a no. Security updates, obviously since the runtime is on premise, you would have to manually do the patch and upgrade to the runtime as and when required. Shared resources, now since if it is on premise, you have full flexibility to control the runtime, so you can deploy multiple applications into single runtime and leverage the domain projects. So runtime fabric and hybrid are almost similar. Only thing is that RTF gives you the ability to dynamically scale your application horizontally using Docker and Kubernetes. So high availability, yes, you get it. Load balancing, the basic means the load balancing between two Docker containers. On top of that, you obviously have your on-prem load balancer, so that's not a concern over here. Logging, again, no, you do not get logging. Monitoring, yes, you get monitoring with RTF. Object store, again, we need to configure. Scheduling, no. So it's almost the same thing. And shared resources is no, because again, that's a Docker container, and a Docker container will have one single Mule application in a runtime, so shared resources would be a problem. Private cloud edition, again, high availability, we need to configure. Load balancing, we need to configure that as well, because even the runtime plane and control plane both are on the on-premise data center, so we can leverage the existing load balancer present with the organization. Logging using the control plane, the logs that we are able to see on the control plane in case of CloudHub, those type of logs cannot be seen using the control plane. So you have to leverage third-party logging mechanisms like Splunk or ELK. Then monitoring only alerts. You cannot see the utilization and all those status, so you can just trigger alerts when you are using the PCE edition. Object store, again same as hybrid, you need to configure. You do not get a v2 access. Scheduling is also no. Security updates, obviously it's on-prem, so manual. And shared resources, of course yes you can, because you have the whole control of the runtime, Mule runtime. And PCF is yet another variant of PCE, so even PCF will have all the same feature as PCE. The only difference is that PCF and PCE, the difference is that you have a pivotal cloud Foundry layer on top of the infrastructure. So that's it about the different deployment models. I hope you might have found this video useful. Thanks for watching.